That's just for the graduate program. Did I went down the wrong link? I don't know exactly, but you can also go to assist.org. Okay, that would be helpful because assist.org would actually tell you how one class from here is equivalent to another class over there that you have to take. So I can actually see what other class, which class is equivalent to that one. Well, what I want to do is to find out exactly why it is required for a math major. Well, apparently it is. Okay, agreements.
The second one.
Oh, okay. There we go. Select a major, math. Are you going after a bachelor's of science?
Yeah.
Okay, so here we go. Okay, cisp300 from here is equivalent to ECS30, which is their own version of C programming. So these two classes, I can tell you right away, they are actually equivalent classes. So it does not explain why you have to take that class, but it does show that if you do not take it here, you still have to take the same class over there.
Yeah, I'm just curious how it relates to a math major, though. What in CSIP 360?
Okay, you have to look at 360 or C programming as a very general programming language. Okay, basically, it is available for all possible platforms. So that's why if you know how to program in C++, you can write programs on just about any platforms. So the bottom line is, why do you need to learn programming as a math major? And the answer is basically, as a math major, what kind of jobs will be available? That's the bottom line. I mean, it's basically after you graduate, what kind of a job will you expect to be available? Do you know? I mean, because I'm not a math major, I cannot answer the question.
A teacher at a college level.
Teacher at a college level. Now you know the programmable calculators like the TI-89, the TI-82, and so on. They're all programmable, and so that means if you know programming, you can actually have the calculator to automate some of the tasks that you have to do as a mathematician. Also in mathematics, not in a teaching capacity, but as a math graduate, a lot of times you'll be employed to do modeling. Modeling means, okay, does everybody understand what is modeling in terms of scientific/engineering applications? Not the, modeling as in fashion modeling. Okay, so modeling is a very, important topic. People try to do modeling with economics. In other words, they look at all the indicators, they look at all the changes, and they're trying to find out, is it going to be better next year? How much better is it going to be, and how things will change, depending on these multiple factors. And in order to do modeling, you need to have a strong background in math because you need to understand a lot of differential equations. But at the same time, you cannot just do it dry on a piece of paper because you actually have to run the numbers through the system. As a result, programming becomes useful. Okay? They could have picked the Visual Basic. The only reason why you cannot use Visual Basic, CISP 370, to put this requirement is because UC Davis itself does not have Visual Basic. So that's why the only class they have in the computer science department is C and C++, and as a result, only this class can articulate with that class over here. There are some other programming languages that will be more suitable, like Python or even Perl is probably more suitable for that, for what you're doing. But since those classes are not available over there, there's no articulation for those classes. Okay. Any questions at this point? questions? Okay. Do we have any questions about subroutines? Do we have any questions about the return statement? Yep.
Yeah, I'm a little confused on the return.
Okay. From my Monday, Wednesday class, I kind of get an idea that that's a kind of confusing topic, especially when there are two invokes on the line of a return. Then what do we do, right? Okay. So what I'll do is I'm going to borrow a program that we are doing with the other class, and talk about it in this class because I think it is a good sample program to take a look at. And if people want to have a okay, let me just open that file first, and then we'll talk about it. Okay, so that's from yesterday's P300 class. And I'll save it to today's class folder, so you guys will have a copy of that as well. Today is the 2nd, and this is P300. Okay, so here is my sample program. It doesn't look too bad. If you look at the length of the program, it's not bad. But this program is a combination of many things that we have talked about so far regarding subroutines. Okay, let's go ahead and just scan the program first, and then we'll deal with the trace. Okay, let's just take a look at the subroutine. The subroutine S5 has two parameters. It has a parameter n, which is passed by value. It has a parameter x, which is passed by reference. In other words, I'm mixing, this is not the first time we have both types of parameters of the same subroutine. It has a very typical signature of a recursive subroutine. It checks whether a parameter is meeting a particular criteria. A particular criterion. If it does meet the criterion, it will stop the recursion and it will just return a value. Except in this case, before it returns the value, it changes the parameter x, which is passed by reference. Okay? So there's a side effect to this subroutine. In addition to returning a value, it also changed something else that does not belong to the subroutine. The else case, which means if n does not equal to 0, it will change x2, but this is the killer. Okay? On this line, this is a return statement, but it is returning the result of two invocations of S5. Each one will pass n minus 1 to n to make sure that the recursion will end at some point. And then whatever the first one returns and whatever the second one returns, I will multiply those two. So the product becomes the actual return value of this return statement. Okay? And that's the subroutine. Outside of the subroutine, I have one global variable k, which is initialized to 1. And then I just go ahead and invoke S5, use 2 as my parameter, and I want to print the result returned by S5. Okay? Any questions about the setup of the pseudocode? Yep.
Now, isn't your print invoke redoing the subroutine one more time?
No.
Okay.
Well, that's not how I would put it. I mean, I'm not sure exactly what you mean by...
Well, you do it twice in line 9.
Oh, this is going to be doing more than twice. I mean, when we run this program, you'll see that it's going to redo line 9 quite a few times. Okay, so we'll go ahead and trace this code. The trace is already fully done in sheet 2, which is not going to be very helpful if I just kind of quickly go through that. So what I'll do is I'll use sheet 3 to basically start the whole thing from scratch and reconstruct the entire trace in this class. If I cannot do it, if I don't have enough time to finish the entire trace, I will send the video clip from my Monday, Wednesday class to this class. Because in that class yesterday on Wednesday, we did finish the entire trace, and multiple students from that class said, oh, this is the best trace ever because it made everything clear. Okay, what does the return do? what do we do at the end of a subroutine? Okay, because those two are the source of confusion. Okay, so we'll try our best to finish as much as we can, but I will also try to answer questions as much as I can as we go ahead and trace this program. We have column A for comments, okay, because we have conditional statements and also a print statement here. We'll use column B for line number, typical of programs like this. And column C will be my global variable k. We do have one single global variable here as k. The precondition is we don't know anything about k. And then on line 12, which is the first line of action after the definition of the subroutine, we initialize k to 1. Are there any questions at this point? So far it's fairly standard stuff. We have a global variable, we initialize it, and that's it. Line 13 is the beginning of the whole big mess. Okay. What do we do on line 13? Can I just go ahead and print something and be done with the whole thing? I can't. Why not? I don't know what to print, right? Because until I invoke the subroutine S5 and know what value it is returning, I cannot print because I don't know what I'm supposed to print. So the first thing I have to do on line 13 is to invoke S5. Every time you invoke a subroutine, you need to know somehow where to go back to. In this case, should I use return line number and just say I'm supposed to return to line 13 or post, or should I use return info so I know which line to return to and also what else I have to do on that line? Return info. Very good. I revised my notes also because of yesterday's lecture, so you might want to read it again because I have kind of sprinkled additional clarifications into the notes. So the return info will do two things. One, it has to indicate which line am I going back to, but it also spells out portions of that line which represents what else do I have to do when I get back to line 13. The invocation, which is invoke S5, 2 goes to n, k is specifying x, that portion is replaced by a single question mark because the question mark is a placeholder for the return value of this invocation. Are we doing okay so far with this, the concepts? Okay. Now, when you invoke a subroutine like S5, you also have to specify all of its parameters. We have parameter n, which is passed by value. We have parameter x, which is passed by reference. What should I do with parameter n here? That's an easy one. The invocation specifies 2, so we'll just make it 2 because it's passed by value. Column E has its own value. What about column F or is passed by reference? It is AKA is an alias of column C because I use k as an argument to parameter x. K is a global variable. It lives in column C. So that's why x is passed by reference. It is an alias of column C. Now that I have columns D, E, F all set up, we can go into the subroutine and start execution inside the subroutine. In the subroutine, we start with the first line that has any action, which is line 4. Line 4 checks whether n equals to 0, and the answer is false. It is not, because n has a value of 2. That means we have to jump all the way around the then portion. We go all the way to the else portion, starting on line 8. Line 8 is just going to add 2 to x. X is an alias of column C. Column C has a value of 1. 1 plus 2 is 3, and we store the 3 back into column C. Is that okay so far? Okay. Then we go to line